In this video, we're going to be looking at binomial theorem part 2, and this is basically based on is mainly based on negative power expansions and fractional index expansions. So we'll learn how to determine the terms of the expansion, the coefficients, and then the values for which such expansions are valid. So the first thing to know here is the negative power expansion, and it's important to note according to the negative index rule of indices that a to the power negative m is equal to a 1 over a to the power m, right? So just in the case of 3 to the power negative 4 is same as 1 over 3 to the power 4, which is 1 over 81. Do you get? So in the case of function that still exists, let's say we have 1 plus 3x to the power negative 4. We could rewrite it as 1 over 1 plus 3x to the power 4. That is without the negative power. So if you have a negative index, it's same as 1 over that same stuff without the negative power. Do you get? And then considering the binomial theorem we explored in part 1, which is x plus y to the power n equals to the summation from k equal to 0 to n of n combination k times x to the power n minus k times y to the power k, right? So we'll see how we could then apply it here. But before we go into that, there's one important thing you have to know about such expansions that have negative powers, and it's the fact that they never end, right? The expansion is infinite. The powers of x keeps increasing. You get? So you notice that x is normally on the right hand side of the binomial. I'll explain that further, but still applying the principles of the binomial theorem, which is you start off by doing what? N combination 0 x to the power, you get. So let's see how we can apply it here. So in this case it says obtain the first three terms in the expansion of 1 over 1 plus x. Applying what I just said now, I said that a to the power negative n is equal to what? 1 over am. So in this case, it was expressed in the form of 1 over am. So it's actually 1 over 1 plus x to the power 1, which is equal to 1 plus x to the power what? Negative 1, according to what is here. You get? So 1 plus x to the power negative 1. Then applying the principles, what are we then going to have? We have not watched part 1 of this theorem. Please do well to watch it so that you can have a clear understanding in case of any doubts or any questions. Right? So we have 1 plus x to the power negative 1. Starting from n combination 0, we're going to have n combination 0, 1 to the power n minus 0, x to the power 0, plus that is 1 to the power n minus this, then x to the power this, then n combination 1, 1 to the power n minus 1, this minus this, then x to the power 1, plus n combination 2, 1 to the power n minus 2, x to the power 2, right? The job is done. So if you watch part 1, we discover that n combination 0 is actually 1 because we have n factorial over n minus 0 factorial 0 factorial, and we said that 0 factorial is 1, proved it in that. So n minus 0 is n, so this cancels this, and then we just have 1. So this is 1. We also said that any number raised to 0 is actually 1, right, except 0. And then 1 to the power n minus 0 is still 1, right? So then plus n combination 1, we also proved that n combination 1 is equal to n, because n combination 1 is what? N factorial over n minus 1 factorial 1 factorial. So n factorial is same as n into n minus 1 factorial, and then over n minus 1 factorial 1 factorial, and then this cancels. 1 factorial is 1, so we are just left with n. So that's n. 1 to the power n minus 1 is still 1, and then x plus n combination 2 is what? N factorial over n minus 2 factorial 2 factorial, get, multiplied by x squared. And then we can simplify this. How can we simplify this? N factorial over n minus 2 factorial 2 factorial is equal to n. So we'll now simplify this n factorial such that this n minus 2 factorial cancels out. We're going to have n into n minus 1 into n minus 2 factorial over n minus 2 factorial 2 factorial. So this cancels this, and 2 factorial is the same as what? 2 times 1, which is 2. we're going to have n into n minus 1 over 2. So in general, you should note that n combination 2 is n into n minus 1 over 2. So that's 1 plus nx plus n into n minus 1 over 2x squared. Then you just substitute the value of n, and in this case 1 plus x was raised to the power of negative 1. So you simply substitute negative 1 anywhere you have n. And what's that going to be? 1 negative x plus negative 1 into negative 1 negative 1 all over 2 x squared. Are you following? So that will be 1 negative x, and then negative 1 over here is negative 2. That's plus negative 1 times negative 2 is positive 2. So we simply have 2 over 2 x squared. So it's simply 1 negative x plus x squared. And these are the first 3 terms in the expansion. I hope you grab. So I want you to pause the video and attempt this question. This says you should obtain the first 3 terms in the expansion of 1 over 1 plus 2x to the power 3. 1 over 1. Have you paused the video? Okay. So in this case, now applying what I said, a to the power negative m is equal to 1 over a to the power m. We can say that 1 over 1 plus 2x to the power 3 is equal to 1 plus 2x to the power negative 3. Do you understand? So, because according to this, right, in this case, it was expressed as 1 over am, right? So, in this case, m is 3 because it was raised to 3. And then we can write it as a to the power negative of that m, which is 3, right? So, using the binomial expansion, we now have n combination 0. You don't put negative 3 first, right? You start with n. So, that's n combination 0, 1 to the power n minus 0, 2x to the power 0, plus n combination 1, 1 to the power n minus 1, 2x to the power 1. And then lastly, you have n combination 2, 1 to the power n minus 2, 2x to the power 2. And the job is done. What's n combination 0? We said it is 1. So 1 times 1 to the power n minus 0, which is 1. 1 to the power n number is 1, right? So we're going to have 1 plus, remember I said that n combination 1 is the same as n. We've proved it. So that's n multiplied by 1, which is 1 multiplied by 2x. So that's n into 2x plus, and we said that n combination 2 is what? N into n minus 1 over 2, and then 2x all squared. 2 squared is what? 4. X times x is what? X squared, right? So this cancels this. We're going to have 2. So with that, what happens next? We can write this as 1 plus n into 2x plus, since this has divided to give us 2, we can write this as 2n into n minus 1 x squared. Once you have this, the job is done. Simply substitute n, which is what? Negative 3. Because you substituted what? You've expressed it in this form, right? As negative 3. So anywhere you see n, substitute negative 3. And that will be 1 plus negative 3 into 2x plus 2 into negative 3 into negative 3 negative 1 x squared. Those are the first 3 terms. Now let's simplify. Negative 3 times 2x is negative 6x. So we then have 1 plus minus is minus, so that's negative 6x. Then 2 times negative 3 is negative 6. Agreed? The negative 3 negative 1 is negative 4, and then you have x squared. Negative 6 negative 4 is going to give us a positive 24. And then we have 24x squared. And then these are the first 3 terms. I hope this is what you got. Right, so that's it. Then you should be able to solve this too. Pause the video and attempt. It says determine the fourth term in the expansion of 2 negative x to the power negative 1. Applying the same principle. Remember, if you've watched part 1, we learned how to list out the terms. We learned how to determine the nth term, right? So apply that here. Have you paused the video? Right. So from part 1, we said that the first term, because from the binomial theorem, we are starting from k equal to 0. Look at the formula right here. We are starting from k equal to 0. So that's why you must be very cautious here. So the first term begins with n combination 0, the second n combination 1, the third n combination 2, n combination 3, the fourth, right? So don't make the mistake of using n combination 4 to calculate the fourth term. because it's all started from 0. So to calculate the fourth term, to determine the fourth term, what you have is n combination 3. Remember, you will not substitute n here because it's negative. N combination 3, 2 to the power what? N minus 3. Agreed? Then negative x to the power what? 3. The job is done. Simplify n combination 3. If you simplify n combination 3 using the factorial formula, let me write it here. N combination 3 is equal to n factorial over n minus r factorial. So for n combination 3, we have n factorial over n minus 3 factorial, right? Which is n into n minus 1 into n minus 2 into n minus 3 factorial over n minus 3 factorial, 3 factorial. So this can cancel this. And what is 3 factorial? 3 times 2 times 1, which is what? 6. So n combination 3 is simply n into n minus 1 into n minus 2 all over 6, right? So with this now, what happens next? So we have n into n minus 1 into n minus 2 over 6. Remember, this is what we are doing now, multiplied by 2 to the power n minus 3. Then what is negative x to the power 3 is what? Is negative x cubed, because negative x times negative x is x squared. Then x squared times negative x is what? Negative x cubed. Agreed? So with this now, you just simply substitute n. Remember, it was raised to what? Negative 1. So anywhere you see n, substitute negative 1. What will you have? Negative 1 into negative 1 negative 1 into negative 1 negative 2 all over 6 multiplied by 2 to the power negative 1 negative 3 multiplied by what? Negative x to the power 3. And then simplify this. Negative 1 is what? Negative 2. Let me simplify it over here. Negative 1 is negative 2. We can have negative 1 into negative 2 into what? Negative 3 all over what? 6. So negative 2 negative 3 is positive 6. So this cancels this and we are left with negative 1. Do you agree? So that will be negative 1 into what? 2 to the power. Negative 1 negative 3 is what? Negative 4 into what? Negative x cubed. So this negative and this negative turns to a positive, and then our final answer is 2 to the power negative 4 x cubed. And then what is 2 to the power negative 4? Remember what I said for negative powers, and I said that what? A to the power negative m is equal to what? 1 over a to the power m. Do you remember? So 2 to the power negative 4 is same as what? 1 all over 2 to the power 4. Then we have x cubed. And what's 2 to the power 4 is what? 16. So our final answer can be written as 1 over 16 x cubed, and that is the fourth term of the expansion. Hope you get it, right? But I'm going to look at the fractional index expansion, and it's a case where you have a fraction that is actually being raised to that expression given. So let's consider an expression in the form a to the power m over n, and this is equal to the square root of the nth root of a to the power m, right? If you've studied indices, this should not be a problem for you, right? You have a to the power m over n is the nth root of a and then to the power m. So let's say you are asked to find 64 to the power 2 over 3. What's it going to be? The cube root of what? 64 raised to the power what? 2. Do you agree? So what's the cube root of 64? What will you multiply thrice? That will give you 64. That is simply 4. Right? Because 4 times 4 times 4 is 64. Then 4 squared is what? 16. The same thing applies to functions. If maybe you are given third root of 1 plus x plus 2x squared, is the same thing as what? 1 plus 2x squared to the power what? 1 over 3. Do you get? It's the same thing as 1 plus 2x squared to the power what? 1 over 3. Look at this. This is the n. It was raised only once. There was no power, so it's typically raised only once. So you can see that what you have as up here is what? 1. Then the denominator is the nth root, which is 3. So third root. So let's answer this question. it says obtain the first three terms in the expansion of the square root of 1 plus x squared. Note that in the square root form, they don't have to put 2 there, right? 2 is not put in that expression, so you should know that it's the square root we are talking about here, right? So we have 1 plus x squared. So considering the general form that says a to the power m over n equal to the nth root of a to the power m, what is n here? It is 2. It was raised once, right? Because there was no power other than 1 here. So we could write square root of 1 plus x squared as what? 1 plus x squared to the power m, which is what? 1, all over what? N, which is what? 2. That's 1 plus x squared to the power half. So applying the principle, it says obtain the first three terms. The same thing. N combination 0, 1 to the power n minus 0 multiplied by x squared to the power 0. Agreed? Plus n combination 1, 1 to the power n minus 1, x squared to the power what? 1. Plus n combination 2, 1 to the power n minus 2, x squared to the power 2. The job is done. N combination 0 is 1. 1 to the power n minus 0 is 1. And then x squared, any number raised to 0 except 0 is 1. Then plus n combination 1 is what? Is n. We said that before. And then 1 and then x squared. So that's nx squared. Then plus n combination 2. We said it earlier. Is what? N into n minus 1 over 2. And then x squared to the power 2. Remember power law that says that a to the power x to the power y is equal to what? Axy. So x squared all squared is x to the power 2 times 2, which is what? x4. You get. So with this now, you simply substitute n, and in this case, what is your n? Half. That is what you are raising it to in this case. We are not talking about this, the general form we're talking of. In this case, we are raising it to half. So anywhere you have n, substitute half. So what is that going to be? 1 plus half x squared plus what? Half into half minus 1 all over 2x4. And the job is done. What is half minus 1? What is half minus 1? Over here, the same thing as half. Half minus 1 is half minus 2 over 2, which is negative half, right? And then negative half times this half. Negative half times this half is going to be negative. Let this thought be clear. Negative half times half, which is negative 1 over 4, and then all over 2. What's negative 1 over 4 divided by 2? Negative 1 over 4 divided by 2 will be equal to negative 1 over 4 times 1 over 2, which is what? Negative 1 over 8. So let's come over here. So we have 1 plus 1 over 2x squared, and then we have negative 1 over 8 x4, and these are the first three terms of the expansion. 1 positive half x squared and negative 1 over 8x to the power 4. So with what I just explained, I want you to obtain the first 4 terms in the expansion of the third root of 1 minus x. Sorry. Let me know what you have, right? I may not know, but just pause the video and attempt so that you could actually build your understanding of this, right? So have you paused it? So if you have third roots of 1 minus x, using this form, a to the power m over n is equal to the nth root of a to the power m. What is our n? Is what? 3. What is n? Is 1. So we can rewrite this as 1 negative x to the power what? 1 over 3. Applying the same principle, we have n combination 0, 1 to the power n minus 0, negative x to the power 0 plus n combination 1, 1 to the power n minus 1, negative x to the power 1 plus n combination 2, 1 to the power n minus 2, negative x all squared. Then lastly, we have n combination 3, 1 to the power n negative 3, and negative x to the power 3. And those are the terms. So we simplify. And on simplification, what are we then going to have? We're going to have 1, n combination 0 is 1, negative x to 0 is 1, 1 to the power n negative 0 is still 1, so plus n, and then negative x Agreed? Then plus, what's n combination 2? Remember, it's n into n minus 1 all over 2. And then negative x to the power 2 is what? Negative x times negative x, which is what? X squared. Then lastly, remember, you go back, you see that we derive the expression for n combination 3, which is n into n minus 1 into n minus 2 over 6. And then negative x to the power 3 is negative x cubed, because negative x times negative x is what? Negative x. Negative x times negative x is x squared, then x squared times negative x is negative x cubed. So let me erase this and then so that we complete what's happening here. Right? So with this now, the job is done. All you simply need to do is to do what? Substitute n. Substitute n. This is n into negative x. Sorry for that. So all we now need to do is to substitute n. Anyway, you see, and what are you going to substitute? It's going to be negative. It's going to be 1 over 3 because it was raised to 1 over 3. Right? So with that, we're going to have 1 plus 1 over 3 into negative x plus 1 over 3 into 1 over 3 minus 1 all over 2x squared plus 1 over 3. I'm substituting here right now for this part. I'm going to have 1 over 3 into 1 over 3 minus 1 into 1 over 3 minus 2 all over 6. And then negative x whole cube is, we already have it here, which is negative x cubed, right? So with this, we could simplify, right? And on simplification, watch over here. Let me clean this off and do my simplification. And let's know what we're going to arrive at. Okay. Let me see. Yeah. So with that now, if you simplify this part, let's simplify this part. 1 over 3 minus 1 is 1 over 3 minus 3 over 3, which is negative 2 over 3. Right? And then, remember, we have another 1 over 3 at the back. So that's 1 over 3 negative 2 over 3, which is what? Negative 2 over 9. And then there's a 2 under, right? So what's negative 2 over 9 divided by 2? Is what? Negative 2 over 9 times 1 over 2, which is what? This cancels this, right? So we are left with negative 1 over 9. Do you agree? So let's simplify this third term. What's 1 over 3 minus 1? We've gotten it as what? Negative 2 over 3, right? And then what's 1 over 3 minus 2 is the same as what? 1 over 3 minus 6 over 3, because 6 over 3 will still give us 2. And 1 minus 6 is negative 5, and then that's negative 5 over 3. Do you agree? And then in general, what are you then going to have? Remember, there is a 1 over 3 here, multiplied by what? Negative 2 over 3, multiplied by what? Negative 5 over 3. Negative 2 times negative 5 is what? Positive 10. And 3 times 3 is 9 times 3, 27. And then remember, it was divided by 6. Remember, I hope you are following me. That's 10 over 27 divided by 6, which is going to be 10 over 27 times 1 over 6, which is going to be 10 over 27 times 6 is what? 27 times 6 is going to be 2, 4, and then that's 162. Are you following? So 2 is a common factor here. So 2 into 10 is what? 5. 2 into 162 is what? 81. So what's our final answer? We've simplified everything. What's our final answer? It's going to be 1 over 3 times negative x is negative 1 over 3x. So that's 1 negative 1 over 3x. We've simplified the second term and we got negative 1 over 9, right? We got negative 1 over 9. And then that's x squared, and then positive 5 over 81 x cubed. Okay, we have a negative here, right? We have negative x cubed. So times negative x cubed. So we can write our answer as 1 negative 1 over 3x, negative 1 over 9x squared, negative 5 over 81 x cubed. Because of this negative x cubed that was over here, we simplified and we had 5 over 81. Then because of this negative x cubed, we now have this. So those are the first 4 terms of the expansion. I hope you are getting it. Okay, so I want you to attempt this based on how we were able to determine coefficients of terms in part 1. I want you to attempt it. Pause the video and attempt. If you can't, just watch and let's see what we are going to do. So in this case, we have 1 plus x to the power 2 over 3. It's the same principle we already did in part 1. All you simply need to do is what? N combination a value k, which you don't know, right? Following the principle, n combination k will be multiplied by 1 to the power n minus k. K is a constant we are looking for. Then x to the power what? K. Do you agree? So now you can see that these components don't have any relationship with what? X. But we are relating this with this. We need something that will give us an x cube. So if we now compare xk with what? X cube, what are we going to have? Comparing the have equal base, we can therefore see that k is what? 3. So simply solve at n combination 3. And that will be n combination 3, 1 to the power n minus 3, x to the power n minus 3. Sorry, x to the power 3. Do you get? And then what's n combination 3? We said it before. N into n minus 1 into n minus 2 all over 6, and then x to the power 3. Because 1 to the power n minus 3 will still give you 1, no matter what the value of n is. So what do you simply do? Anywhere you see n, you substitute the power, which is what? 2 over 3. So that will be 2 over 3 into 2 over 3 minus 1 into 2 over 3 minus 2 all over what? 6. So what is 2 over 3 minus 1? 2 over 3 minus 1 is the same thing as 2 over 3 minus 3 over 3, which is what? Minus 1 over 3. And 2 over 3 minus 2 is simply 2 over 3 minus 6 over 3, which is minus 4 over 3. So with this now, what are we having? 2 over 3 into minus 1 over 3, right? Into negative 4 over 3. And then on simplification, 2 times negative 1 is what? Plus negative 2. Now negative 2 times negative 4 is positive 8. And then we have 8 all over 3 times 3 times 3 is what? 27. Remember, we are dividing by 6. So 8 over 27 divided by 6 is the same as what? 8 over 27 times 1 over 6. And 27 times 6 is what? 162. Right, so that's 8 all over 162. And I think 2 can go here to give us what? 4. Right? And 2 can go here to give us what? 81. Right? So with this now, what's the first term? And remember there's an x cube. Don't forget the x cube. So since you were asked for the coefficient, you know the meaning of coefficient, what rests behind that particular stuff? And in this case it's x cube. So what is carrying x cube is simply what? 4 over 81. So the coefficient of x cube is what? 4 over 81, because we are just solving for this part, right? This part is the coefficient, this is the expression x cube, right? Okay, so this question is a combination of negative and fraction, right? Same principle, nothing different. Following the steps, what are we going to have? Remember, this is 1 over x to the power negative 3 over 4. Sorry. So in this case, what are we then going to have? N combination 0, 1 to the power what? N minus 0, negative x to the power 0, plus n combination 1, 1 to the power n minus 1, negative x to the power what? 1, plus n combination 2, 1 to the power n minus 2, negative x whole squared. You solve the question. You know this is a CBT exam, so you have to be fast. Please if something like this comes. Right, so negative x to the power 0 is 1, 1 to the power n minus 0 is 1, and then n combination 0 is 1. So that's 1 plus, remember n combination 1 is what? N. So that's n into negative x, then plus n combination 2 is what? n into n minus 1 over 2, remember, and then negative x all squared is negative x times negative x, which is what? X squared. Then what do? Substitute anywhere you have n, substitute what? Negative 3 over 4. Are you following? So that will be 1 plus negative 3 over 4 into negative x plus negative 3 over 4 into negative 3 over 4 negative 1, right? All over 2, and then you have x squared, and then it keeps increasing. So let's simplify negative 3 over 4 negative 1. Negative 3 over 4 negative 1 is same as negative 3 over 4 negative 4 over 4. Or you could use the LCM to get it. Anyway, because negative 4 over 4 is negative 1. Right, so that's negative 7 over 4. And then we can then simplify this part. Hope you are not lost. This numerator as negative 3 over 4 into negative 7 over 4. And negative 3 times negative 7 is positive 21. 4 times 4 is what? 16. And remember that we divided by 2. Hope you've not forgotten. So what's 21 over 16 divided by 2? 21 over 16 divided by 2 will be equal to 21 over 16 times 1 over 2, which is what? 21 over 32. Are you following? So with that now, going back to what we have, negative 3 over 4 times negative x, negative, and the negative becomes a positive, so that will be 1 plus 3 over 4x. We've simplified negative 3 over 4 into negative 3 over 4 negative 1 over 2 x squared, and we got what? Positive 21 over 32. And that's what, remember, there was an x squared attached. So these are the first 3 terms of the expansion of 1 negative x to the power negative 3 over 4. Then lastly, in this video, we are going to be looking at the determination of the set of values for which expansion is valid. And in this case, remember, we are looking at the negative expansions, we are looking at the fractional indexes. How do we get the set of values? Because remember that this is an infinite sequence, right? And if it's an infinite sequence, using the convergence rule, right? Convergence means it has to get to that particular point, and divergence means it actually goes away from the actual function. So we don't want it to diverge, because if it diverges, it's no longer complying with the original function. So what are those values that we need that show that gives us the set of values for which the expansion is valid? So looking at the screen, for binomial expansions where n is negative or fractional, such expansions are infinite, unlike those where n is positive. Just like in part 1 we looked at positive n. Just like if you expand 1 plus x all squared, what is it going to give you? 1 plus 2x plus x squared. It has an end, right? Because this n is positive, but as it's negative, it's not terminating, it's going to infinity, right? So due to this, it is crucial that we learn how to determine the set of values for which such expansions are valid or is valid. There are some values that lead to what? Divergence, that would now diverge from the original function, and that's not what we want, skewing the original graph. So we are now looking for that part of the expansion that complies with the graph of the negative expansion or the fractional expansion. So what are the steps to achieve this? 1. The value of n is independent of the set of valid values for expansion. That's in the case of fractional and negative expansion. So if we have 1 plus x to the power negative 3 and 1 plus x to the power negative 4, the set of values for which the expansion is valid is independent of the value of what? These powers, this negative 3, this negative 4. It's just that having the knowledge that the powers are negative, you know that such sequences have no end. There are certain values that the expansion would not comply by, right? So it's not the value of n that helps you determine these values, right? Then number 2, simplify the expression in terms of 1 plus x, and then you see I inserted 2 dots, meaning that x could also have other things associated with it, and then to the power n. The absolute part of the absolute value of the part containing x should be less than 1. This obeys the convergence rule, because outside such values, what happens? it leads to an infinite. Expansion, it leads to divergence. You get it? So how are we going to practicalize this now? So let's see, we are given this. Let's use a previous example where we had 1 over 1 plus x. I follow it. So 1 over 1 plus x can be written as 1 plus x to the power what? Negative 1. Do you agree? So this part is the part, this contains x. And remember, is in terms of 1. Are you seeing what is happening? It's in terms of what? 1 plus x. Look at what I have here. 1 plus x. So in this case, you can simply do what? Say that the absolute value of x should be what? Less than 1. Do you get? Absolute value, these are the set of values for which what? The expansion is valid. Because outside these values, maybe you are now using 2, 3, there will be a divergence from the original curve, which is 1 over 1 plus x. And if you look at it graphically, you would see that there's actually a change, something like this. I'm not sketching it perfectly, but you see that it has asymptotes present in it. So by the time you now go out of this boundary, what happens? There's a divergence. You grab. So in this case now, we have absolute value of x should be less than 1. And then we could also simplify this. If you have absolute value of x, if you've watched my video on introduction to functions, you see where I said that an absolute value function, if the input is positive, is going to transpose it to what? It will still be positive. If the input is negative, it transposes it to what? Positive. So what happens here? You will now solve for what? X less than 1, which is agreed, and then you solve for negative x, because it's possible for x to be negative, and then by the time you are finding the absolute value, it should be less than 1. So negative x less than 1. And if we solve this, we divide both sides by negative 1, and there's a consequence to this. Anytime we divide by negative in an inequality, the sign changes. So this cancels this, and then 1 over negative 1 is negative 1, so that becomes x greater than negative 1. So we can combine these two inequalities, right, as what? If x is greater than negative 1, you'll agree with me that what? Negative 1 is less than x, and x is what? Less than 1. So this is another way of expressing the answer, right? Or using interval notation, we can simply say this: from negative 1 to 1, excluding negative 1 and 1, because negative 1 and 1 are not included. You get? Because it's not less than or equal to. It has to be less than 1. You get? Okay. So let's take another. I want you to pause the video and attempt this question I'm about to give you now to solve, to determine the set of values for which the expansion is valid. And that's simply 1 plus 3x to the power negative 4. Right? If you're asked this in the exam, determine the set of values, what do? You can see that it's expressed in terms of what? 1 plus an expression containing x. That's the reason I use those two dots. So it doesn't just have to be x, it could have x, and then other things could also be attached to it, but let 1 be over here. Do you get? So that means that the absolute value of 3x should be less than what? 1. And we can break this down to what? 3 times the absolute value of x should be less than 1. Do you agree? And then dividing through by 3, we have that the absolute value of x should be less than what? 1 over 3. Applying the same principle, we can say that x should be less than 1 over 3, and what? Negative x, because x could be negative, should be less than what? 1 over 3. Dividing through by negative 1, what happens? We're going to have x, because negative cancels this, that's x greater than negative 1 over 3, because the sign will now change. So if x is greater than negative 1 over 3, we can say that negative 1 over 3 is what? Less than x, which is what? Less than what? 1 over 3. So this is the answer. These are the sets of values. And then what happens? In interval notation, from negative 1 over 3 to what? 1 over 3. Because on the number line, this is how to represent it graphically. This is positive infinity, This is negative infinity. So let's say that here is 0, here is 1 over 3, here is negative 1 over 3. And the first inequality we have is that x should be greater than what? 1 over 3. So starting from here, x greater than 1 over 3 and x less than 1 over 3. So you see that they have a meeting point. So this is the interval for which valid, containing the values for which the expansion is valid. So with that, I want you to solve this. If you have 5 plus 3x to the power negative 1 and you're asked to determine the set of values for which the expansion is valid, what will be your answer? You can see that it's not expressed in terms of 1 plus. So you can factor out 5. Do you get? Is this we are concerned? It has to be expressed in terms of 1 plus. So if you factor out 5, it will be 5 into what? 1 plus. Because 5 divided by 5 is what? 1. 3x divided by 5 will give us what? 3x over 5. And then all of this is raised to what? Minus 1. So we can write this as 5 to the power negative 1. 1 plus 3x over 5 to the power of negative 1. So what are we then going to solve? The fact that the absolute value of 3x plus 5, 3x over 5 should be what? Less than 1. Very simple. So this is the part associated with x. And this part, the absolute value of the part containing x should be less than what? 1. You solved it. And then with this, you could cross multiply because this is just a constant. It does not contain x. So we can simply have that the absolute value of 3x should be less than 5. We can bring out the 3 as 3 absolute value of x less than what? 5. Do you agree? So with this now, what are they going to have? The absolute value of x should be less than what? 5 over 3 because we are dividing through by 3. So with this now, this is a possible answer. This is fine. But otherwise, we could also have that x is less than 5 over 3 or negative x is less than 5 over 3. And if we should solve this further, we'll have that x is greater than what? Negative 5 over 3. According to what I've explained earlier. So if x should be greater than negative 5 over 3, that means that negative 5 over 3 is less than x. And x is less than what? Which is this over here. X is less than what? 5 over 3. So these are the sets of values for which the expansion is valid. So we'll take the last question, and then I hope that any question that comes up on this in the CBT exam, you'll be able to ace it. So let's say you are given this in the exam. Third root of 3 minus 2x, and you're asked, determine the set of values for which this expansion is valid. What are you going to do? You can rewrite this as what? 3 minus 2x to the power of what? 1 over 3. You understand? And then what happens? You can see that this is not 1 though, so you factor out 3. So 3 into what? 3 divided by 3 is what? 1. Then negative 2x over 3 is what? Negative 2x over 3. And then to the power what? Each of them to the power 1 over 3. So what you're now going to solve now is negative, the absolute of negative 2x over 3 should be less than 1. Are you following? So from this, you know this identity, the fact that the absolute value of negative a is equal to the absolute value of a, because absolute of negative a will give you a and absolute of a will give you what? A. So this absolute of negative 2x over 3 could be rewritten as absolute of 2x over 3 should be less than 1. Following the principle you could do what? You can cross multiply, isn't it? So that means that the absolute value of 2x should be less than what? 3, because 3 times 1 is 3. And then you can bring out to 2 times absolute of x should be less than 3. That means the absolute of x should be less than what? 3 over 2. Do you agree? So that implies that x is less than 3 over 2. And then or negative x is what? Less than 3 over 2. And if we now divide through by negative, what happens? That means that x, the sign is going to change, right? So that's x greater than negative 3 over 2. And if x is greater than negative 3 over 2, that means that negative 3 over 2 is less than x. And from the first expression, x is less than what? 3 over 2. This is the first answer. This is another possible answer. I've written it before. And then the interval notation is going to be what? Negative 3 over 2 to what? 3 over 2. You get it? So in the comment section, I want you to write down the values for which 5 plus 9x to the power negative 3, the values of x for which the expansion is valid. I want to see your answers in the comment section. Thank you so much for watching this video, and I hope you enjoyed it. Do well to like, share and comment on this video. Respond to the question I've written, and then I hope by the time the exam comes you would ace it. My number is on the screen. If you have any questions that relate to anything concerning this or any other aspect of math, do well to contact me with this number. Thank you so much once again, and have a nice day.